Okay, let's go to the top. Let's start at the beginning of what we're doing and why. Okay, so part of my sub-plans have fun activities for you to do occasionally with like M&Ms and stuff, but you know, life. We'll see about that because I don't know. You're stressing me today and I'm here, so I just don't know. We'll see. Okay, are you being cheated out of Skittles? You will conduct a quality control experiment to assess whether the Skittles Corporation has correctly labeled the weight on Skittles bags. Okay, so we had a Skittles bag for everybody. What are the hypotheses for this experiment? What should we do for the hoe and what should we do for the ha to see if we're being cheated out of Skittles? Yes, ma'am. You can pick one. Yes, dear.
Do you have the inverse fractions worksheet?
It was the Friday one. It's in the Friday thing.
It's in the
And
Friday.
Friday was whatever date Friday was. 2 something. 17. It's in the basket. So look at it. 217, 216. I don't know whatever Friday's date was. Crazy. Yes. What's your guess for the hoe?
I'm thinking 0.5.
Okay. Well.
Shouldn't we put what they give us and what the weight they say it is?
Yeah. So that's what I was hoping someone would be smart enough to say. So if we were wanting to know, so we're trying to figure out, are we being cheated out of Skittles? So to know if we're being cheated out of Skittles, don't we need to know the basic weight of a Skittle bag?
Yes.
How could we find that out? It does. It does say on the box.
The total weight is 13.4 ounces.
Okay, so bless it. I actually found I found these on sale because it was after Valentine's Day, so there were stickers in it and everything that they were measuring. So I did write down while I was at the store the normal weight of a bag is supposed to be 0.536. Again, my bag is a little different because my box had all the stuff for Valentine's as well. So I did cheat and find another one at the store. I just didn't buy it because it was more expensive. Okay, basic weight of Skittles bag, and I guess we should be more specific and say it's a mini if you want to, or a fun size, or however you want to specify that's not the giant bag.
Life size.
Okay, so whether the Skittles Corporation has correctly labeled. So we want to know whether or not they correctly labeled their stuff. So that weight that I got off the box, is this actually true or not? So for the ho and the ha, we want to know whether or not we're being cheated. So for the ho, I'm going to say mu is what?
0.536.
And what symbol do I always put for ho? What operator?
Greater equal to.
You always use an equal to when you're doing ho. Always an equal to. The ha can be a less than, a greater than, or a not equal to.
Let's do not equal to.
Literally, because it said, how did I know to do not equal to?
Let's say greater than or less than.
It didn't say greater than or less than. It just said the weight that has been correctly labeled. So are you being cheated implies, I guess, someone argued the other day at our conference, that being cheated implies we're having less than, because is anyone really going to complain if you have more than?
If you're trying to watch your weight or something. Like
So
garbage
I
weight
could
or
see
something.
how if we had all year and we could come back and do this again, I could definitely see why we would maybe pick for the ha the less than 0.536 because of the phrase cheated out. Just because, again, Hunter's not going to complain if he has more Skittles on average. He's going to complain if he has less. So I can see how we could come back and do this again. Okay, since, we should probably be more specific about what mu is. And we kind of wrote it at the top, but, we still want to have the same wording over and over again. So it's the true mean of a fun sized or mini or whatever you called it.
Bite size.
Bite size, whatever it said on the package. Skittles, bite sized.
Yeah.
Size Skittles bag. And then if you're being super specific, you might want to add in parentheses with Skittles inside. Because, if Cody had eaten all the Skittles and just measured the packaging, that's a different thing. Okay, since we're picking not equal to, tell me about this hypothesis test. Since we picked not equal to. So we're going to do some sort of test. And we're going to end up back at that normal curve for the bajillionth time. But there's something specific we should know about this test. Like, I know my mu is here for that 0.536. And we're wanting to figure out, is it above, is it below, that kind of thing. But since we're wanting both the higher and the lower, what kind of test is this called? It said the words last week.
It's one-sided or two-sided?
Yes, it's called a two-tailed. Good.
Wait, two-tailed?
Yeah, so because there's a tail end and a tail end.
Oh, they just call it two-sided.
Okay, so two-sided test or two-tailed test is good. Either one's good. Therefore. Yeah, meaning that we're going to look at if it's below our average or above our average. We're going to look at both ends of the spectrum. We're not just looking for less than, not just greater than. So there's two different ends we have to consider. Okay, so we typed all this in L1, which again is a bit ridiculous because never on earth would you be allowed to type this many entries on an AP or anything else in life exam. I mean, because we would, if we really were running an experiment like this in real life, we would use our our computer. We would probably have the scale hooked up to the computer so it would keep up with the data for us. Because after 36 entries, there's more than likely a typo we're going to make.
I made a typo because I only have 35 listed and there's 30.
Well, it's going to be okay. Okay, so Sally asked a good question, and we're about to answer her question. Summarize our findings. What is our N?
36.
Because there were 36 in our sample. And then, so our X bar and our S, we can figure out using our calculator. Since we've typed this into L1, and where did you go to figure that out?
Calculate one variable stats.
Yes, and you tell it to pick from your list that you typed it in at. And so if Kinsey does this, hers is going to be wrong because she's missing an entry. Did you get 0.48?
You only have 35 entries.
Me, I do?
Yes.
This is number 35.
Oh, calculate. A second. I got distracted. So my L1. You go back to stat and then edit. Let's see. I've got my 0.35, 0.75, 0.25, 0.625, 0.375, 0.35, 0.275, 0.3, 0.2.
You just go to the bottom, it'll say
I know, but I feel like I missed one, and I'm trying to figure out which one I missed. 0.4, 0.7, 0.6, 0.2, 0.25, 0.25, 0.25, 0.15, 0.3, 0.47, 0.4, 0.5, 0.6, 0.75, 0.65, 0.60, 0.75, 0.75, 0.5, 0.75, 0.75, 0.75. I didn't do 0.75 5 times. That's fine. Okay. So I did my one variable stats and I got 0.492.
Yay.
Okay, so my X bar is 0.492. You're on my nerves. I get discrete as unproductive, but you're in a dang AP class. Jeez, take the wheel. Yay. Okay, so you got 0.492 and my SX is 0.201. Okay, so we'll come back and deal with that in just a second, but I'm supposed to, it said summarize my findings, and then you and I are about to try to make some conclusions and stuff, and we need to check some things before we go any further. What do we need to check? We have got to check the conditions, which is going to answer Sally's question of why did I choose the sample size that I chose. That's exactly why. So I did 13 times 2 and said that was 26 and was like, nope, I've got to have at least 30. That's why everyone did 3. So we have got to check our conditions, and we need to be more specific because some people missed on the last test. They, because on the test, in the free response, it did different conditions with different parts. So some people did a normality test for independence and an independence for normality. So we need to probably be more specific. So random.
13 times 3 is not 36, I think.
No.
Well, it was random because we picked them out without that.
Yes, so literally that's what I'm going to put. So randomness is reasonable
I put it with some bias because you go down to the sale.
because randomly distributed,
But there were many on sale.
Are you sure?
distributed to students, or you could say randomly distributed to store. Like Mackenzie's completely right. It's very reasonable because it was randomly distributed, and we could go into why. But I mean, technicalities because I did put one on sale, but there were other boxes on sale. It wasn't like that was my only option. Okay, so independent. Is independent the 30 thing, or is normality the 30 thing?
That's normality.
Normality is the 30. So by CLT, since n is bigger than or equal to 30. So that's literally why I made our sample include this way. It's not exactly what it was supposed to be, but that's why our sample's going to end up working out for us. Sally's not here. Samantha's not here.
Wait, what? Oh, yeah.
The other S, the third S, Samantha. So 12 times 3 is 36. Yes. Okay, but independent, what am I supposed to do for that one?
MP greater than equal to 10.
Okay, and then does anyone know what that's called?
Large numbers thing.
Yes. Okay, so the capital N would be what? Population of,
Skittles bag.
and if we were specific, we would say bite-sized Skittles bags, but yeah. The population of Skittles bags is definitely bigger than or equal to 10 times our 36. It's also called, large numbers is good, it's also called the 10% condition, if that helps you even more. I like 10% condition because it helps me remember, yeah, I'm supposed to use 10.
I thought the 10% was
The NP greater than or equal to, nah, I mean, they're, yeah. Do you have to name them per se? No. Do you need to know independent and normal, the two different tests? Yes. Okay, now I cheated and made us do so many samples. If we hadn't done so many samples and we needed to show normality, what was our second option?
It's robust.
What could you do instead if my sample size isn't 30? Yes.
Oh, yeah.
We could have made us a box plot to make sure that it really was, our sample really was normal looking. Good, Julia, that's good. So if our N hadn't been bigger than 30, we would have had to resort to a box plot, which would have been fine because we already have it all typed in our calculator anyway, so it could have handled it. But nobody wanted to do all that today. Please. Okay, so now we need to go to the back and we'll actually do the math. So since we met the conditions, we can roll. So we're wanting to test our hypothesis at the alpha equals 0.5 significance level. Notice that the conditions haven't changed. And for the love, they're not going to change. They might add an extra step eventually when we get to even fancier testing. When we get to chi-square testing, there's a little extra. But seriously, if you can remember this random independent normal and roll with it, life's good. Okay, so we need to check, we're told alpha is 0.05. Be sure to include your test statistic with degrees of freedom if applicable, and the p-value of your test. Be sure to also check the appropriate conditions. Well, we already did that. Check conditions. Done. So what we're wanting to see, and what did we get for our X-bar?
0.492.
Okay, so we discussed that a normal Skittle bag is supposed to be an average of 0.536. We got a Skittle bag that was, say it again,
0.492.
0.492. So yeah, we need to know down here but we also need to know the same area above up here. Okay, we can do this all on our calculator, which we can discuss in just a second. But for those of us who like to actually work things out by hand, bless you for that.
0.6.
Bless you for that. To find our t-value, our test statistic, we're still going to do our average minus our given minus what we found, and we're still going to divide by something. Wasn't it sx over the square root of n?
Oh. That, yeah.
What was our sx?
0.201.
So we could do all this, and this is great. No one's really mad at that. And if we had to list our degrees of freedom, what are our degrees of freedom right now?
35.
I don't understand the reason for that.
You have 35 different choices, basically. So you have
It's back to the pen thing of, like, right now if I have 2 pens out here, I have an option of 2. But once I select one, I only have 1 left. You'll always have 1 less option in life, because eventually the last option you're stuck with.
Yeah, I get that, but what do you mean, like,
It helps us when we use our chart. Or when we use our calculator. Chi-squared, and it's coming. It's just not here yet. Okay, and while this is great, and this is lovely, and we could find a p-value and everything, wouldn't life be so much easier if we just went straight to our calculator? Okay, so what test am I going to run in my calculator?
t-test.
Why is it a t-test?
Sure.
Okay. What would be our option if it was proportions?
P-test.
Okay.
T-test.
Yes, so we have options. So if you're calling your calculator, we've been stuck on not tests. What have we been using so far? We've been using intervals because we were doing confidence intervals, so it made sense. But now that we're doing hypothesis testing, it makes sense that we're doing tests. Okay, so we have options of z-test or t-test, and they are correct since it's a means problem. How do you know it's a means problem? Because we're discussing the average weight of the packaging. So we are going to do a t-test. So I go, and it says I can input my data, or I can input my stats. You and I both know life is so cool because it already knows our L1 stuff. Yeah. Now, could we do stats and type in the stuff we know? Yes. But God bless it, because we have that giant table, it knows our data. Okay, it automatically is setting it to that. If I want to change it, I can, but I don't feel the need. And then we could keep scrolling down. If we had decided to do a one-tailed test, so like just the less than, we would need to swap it up. But we decided it was going to be not equal to anyway. So perfect, I'm going to click it.
Wait. Why wouldn't we change mu null?
If we can change it if you want to.
Not change to 0.536.
Yeah.
That's not a bad idea. Why am I not doing that? I should. That would make sense. Because isn't that our average for our population? Because mu is asking for the average of the population, and didn't we find it was 0.536?
So, do we need to change anything? Like, it's just gonna say, on the one where the black line.
Yes, we want that one. Yeah, we want that one. We're not going to do the other. So if we press calculate, here we go. So we want to know mu not equal to 0.536, and it tells us all these things. It would probably be nice of us to write these things down, because again, yes, you did a t-test, but unless you can show you can use that information, it's kind of pointless. So it told us u is not equal to 0.536. It told us that our t was negative 1.304.
Is this test really accurate though? Because we all BS our way through that scale.
I know, that was another, yes. Yes and no.
Without actually the scale.
We're going to make that conclusion momentarily, ma'am. Do you think that we did a good job with our sampling and being very specific? No. So could you argue if this was a question that you feel like we should have done a better job? Absolutely.
Yes.
Does it matter
Okay.
if T is negative or positive?
No,
Okay.
because we discussed it was both, because we're doing both tails.
Then it just
Okay, but it said be sure to include your test statistic with degrees of freedom if applicable and the p-value of your test. Be sure to also check the appropriate conditions. So we for sure have the degrees of freedom. Yay.
And the pizza.
We have the T and the P. Yay. That's all that we have to absolutely show. Well, I would say we normally would, except part number 5 is asking for the words. So otherwise, yeah. And you would say, like, hey, I need to use words and explain myself, but number 5 is going to make us do that. Okay, so there was this joke I told last week, and he told it in his video as well. So what we do is we make a hypothesis, then we run a test, and then we decide whether or not that hypothesis is rejected, and we don't say accepted, we said fail to reject. So are we going to accept the hoe or reject the hoe?
we're rejecting the
Fail to reject.
Okay, so again, our options with hoe, we're either going to reject him or we're going to fail to reject. And I really liked last week how he explained it's kind of like in a court case, how you're either guilty or not guilty, and they never quite say innocent. Guilty, that's a guilty. Yeah. Unless new evidence appears. So guilty, not guilty. So reject, fail to reject. We never get to accept the hoe. We're either rejecting or failing to reject. So all this depends upon a cute little phrase that I said, and he said too. What was the cute little phrase? He is low. Reject the hoe. So let's compare our P and our alpha. Our P is 0.2005. They told us our alpha in the problem. Even if they don't tell you the alpha, the understood alpha is the 0.05 if they forget to tell you. So 0.05. So and Louise already answered, this is bigger than, so the P is not low, so we cannot reject the hoe. Fail to reject. So since P is greater than alpha, and I'm even going to put in my numbers, 0.2005 is greater than 0.05, this would be the part you would write for real in life. Fail to reject. Oh, the part with the star. Like, I pray to goodness you don't write P is low, reject the hoe in quotes on your paper. No, I would do both, just so they know that you're not crazy. But as long as you have P greater than alpha, you should be good. So fail to reject the hoe, thank you. It's not my best alpha, is it? Okay, and now we want to be more specific. So that line is great, but as always in stats, you need to relate back to the context. So what was the hoe?
0.5 transits.
Okay, but relate it. It's less mathy words, more what was the problem we were looking into in English.
They seem to be correct in saying that the mean of the average weight of the bag of Skittles.
So we could say the average weight of Skittles is labeled correctly, not incorrectly.
Correct.
The P is low. We failed to reject the hoe.
So hoe must be true.
Okay, but so we failed to reject, which means we accept it, which means we couldn't prove the hoe wrong. So what did the ha say? Because the ha must be wrong. What did the ha say? Okay, specifically we said mu not equal to whatever, 0.5. 536. So, and that was the average of the Skittle weight bag. So we're going to say we couldn't support the high. So evidence does not support. And I'm not literally going to put high. I'm going to put words that describe the high. That weight of Skittles bags, or weight of Skittles, is labeled incorrectly. So yes, so you still are, hypothesis tests aren't that deep. It's just a little, you know, the way confidence intervals were just a step up from what we had done previously. So this is a tiny step up from confidence intervals. You decide whether or not the P is low. You decide whether or not you're going to fail or accept the hoe. And then, you, as always, you need to relate it back to the context of the given problem. So what was the hoe? What were the ha? What were they representing in real life? And in this case, it had to do with the weight of Skittles bags. So sadly, we couldn't find that the weight of the Skittles bags actually is labeled incorrectly. So do we think we did a bad job? No. Because when we did it at our session, we got the same, we did not have the same numbers, but we did end up getting the same results. So the weight of Skittle bags is, on average, labeled correctly. You've had your hint, ma'am. No, if P, like P compared to that alpha level. And the alpha level is given to us on number 4. Look at number 4 on the top line. It says alpha equals 0.05. And so we have to accept, yeah. So we failed to reject the hoe. The P wasn't low, so we couldn't reject the hoe. Okay, Kinsey asked a good question, which is where we left off on Friday. That was the second part of that example that guy was about to do. And so if we went back to change number 4, if we change number 4 to an alpha of, well, normally they do 0.5 or 0.01, but let's make up an alpha. So an alpha of 0.8. Yeah, they're never going to have an alpha that high. But if we did change our alpha level,
Is it always given?
it is, if it's not given, it's 0.05. If it's not given, it's accepted as 0.05. It's most problems I've seen, they're like 0.05 or 0.01. So they're either 1% or 5%. Why? They went through why it was 5 on Friday. Why 1 is the other one, I don't recall. Curious. Let's change it to an 80%, which is never going to happen. That's way too big. But let's say they did. If we compared our P and our alpha then, P is 0.2005. Well, that's way less than 0.8. So in that case, if that happened, we would say since P is less than alpha, and we would put in our numbers, we would reject the hoe. No. You should never get P. P is like the probability, back to that normal curve. It's going to do with the probability of the shading under the normal curve. The two-tailed, say it again, ma'am. Yeah, P's still got to relate back to probability, which got to relate back to the shading under the normal curve. Like, how much did we shade under the normal curve? Okay, and then it says create a 95% confidence interval. If I wanted to do this, and I wanted to do this quickly, what command would I use on my calculator? If I wanted to do a confidence interval of 95%. We'll start on number 6 tomorrow. I hear you packing up. I got to go too. We'll start on number 6 tomorrow.